Dear students and learners, today we will see the Chatelier Principle. So before we move to the Chatelier Principle, we will see little bit about a chemical equilibrium. So in a chemical equilibrium, we have an example: hydrogen and iodine reacts together to form two hydrogen iodides. So in this reaction, there is a forward and a backward reaction, both occurring in same time. So when a system is at equilibrium, that means the rate of forward reaction and the rate of backward reaction both are same. The speed of the forward and the speed of the backward reactions are same at equilibrium condition. So for example, we have hydrogen and iodine in this system, closed system, in initial stage, and we don't have any hydrogen iodide molecules. We have only reactants. So we have 50% of hydrogen and 50% of iodine, and there is even no hydrogen iodide. Now we kept closed and the reaction will start. So at this stage, the 1% of hydrogen iodide will be formed, and then it will be keep on increasing up to 50% of hydrogen iodide. Then the reaction will be going backward, because this is also will be happened. So we will have equilibrium situation. So in the equilibrium situation, we have the forward reaction and the backward reaction at the same speed. So now you understand what is equilibrium. Now we will move to the Le-Chatelier concept. As per the Le-Chatelier concept, a system in equilibrium is disturbed, then the system shifts. The system shifts in a direction. The system itself shifts in a direction to nullify that effect of that disturbance. So for example, we have hydrogen and iodine reacts together to form hydrogen iodide, and we have concentration of hydrogen and iodines. So if we increase, we will take the first step. If we increase the hydrogen concentration, and this is the change done by us. The blue color, it means the change done by us, and change by the system, it will means it is done by the system automatically. And the forward, it means the forward reaction, it favors the forward reaction. This means the favors the forward reaction, and this means it favors the backward reactions. If we increase the hydrogen concentration in the system, then the system will try to decrease. So it will try to, because as per the Chatelier principle, it will try to nullify the effect of that disturbance. So the disturbance means we increase the concentration. So the system will try to decrease the concentration of hydrogen. So how the system can be decrease the hydrogen concentration? So if it is consumed, then the hydrogen concentration in the system will be decreased. So in which way it will be consumed? So hydrogen plus iodine so reacts to form more hydrogen iodide. So if it is forwarding reaction, if it favors the forward reaction, then the hydrogen concentration will be bringing back to the original position. So if we increase that hydrogen concentration, and the system will try to decrease the hydrogen concentration. So to decrease the hydrogen concentration, it favors the forward reaction of formation of hydrogen iodides, more hydrogen iodides. Now we will see the change of concentration of iodine in the system. The same thing, it is also reactant. If we increase the reactants concentration, then it produce more hydrogen iodides. That means it will favor the forward reaction. It produce more hydrogen iodides. In the system, if we reduce the hydrogen iodide concentration, the system will try to increase the hydrogen iodide concentration. So in order to increase the hydrogen iodide concentration, the system will favors the forward direction, so that more hydrogen iodide will be formed. So now in the reverse, so if you decrease the hydrogen concentration, if you decrease the hydrogen concentration, and the system will increase the hydrogen concentration. So how the system will increase the concentration? So it will increase by favoring the backward reaction. So it will favor the backward reaction to form more hydrogen. So it will decompose. So the hydrogen iodide will be decomposed and to produce more hydrogen and iodine. In the same thing like iodine also, if we decrease the concentration of iodine in the system, the same thing, similar thing, the hydrogen iodide will be decomposed and to form more hydrogen and iodide. And if we increase the hydrogen iodide concentration, then it will the system will try to decrease the hydrogen iodide concentration. How it will try to decrease? Then the same thing, it will go back, so it will favor the backward reaction. Let us see the effect of pressure in the Le-Chatelier principle. So we have a system with example of hydrogen and iodine. It gives two hydrogen iodides. So let us see the number of moles in the left side and the number of moles in the right side. We have one number of mole and here one number of mole. So overall two number of moles in the left side, and in the right side also we have two number of moles. So as per the ideal gas law, pressure is directly proportional to number of moles. So here if we have a forward reaction and backward reaction, then total number of moles in either side is same. So there will be no change if you are increasing the pressure or decreasing the pressure. The equilibrium will not be adjusted. If you are increasing or decreasing, it doesn't affect the equilibrium of this equation. And we will see the another equation, nitrogen ammonia formation. So nitrogen and hydrogen reacts together to form ammonia. So 1 mole of nitrogen and 3 mole of hydrogen and produce 2 moles of ammonia. So here total number of moles are 4, and 1 plus 3 4, and here it is 2. Number of moles are 2. So if there is a forward reaction, so in the ammonia formation we have a system with pressure, and in the ammonia formation, if there is an ammonia formation, then the number of moles being decreased, so as the pressure and number of moles are direct relation, so as the number of moles are decreased, the pressure of the system is decreased. So in the forward reaction, the pressure itself in the system will be decreased. Now if we are increasing the pressure, if you are changing the pressure in the system, you are increasing the pressure, the system will try to decrease the pressure. So in order to decrease the pressure, as I said before, to decrease the pressure, it has to move forward. So it favors the forward reaction, so that number of moles will be reduced and the total gaseous molecules, number of molecules will be less, and also the pressure will be less. So if we increase the pressure, the system will try to decrease the pressure. So in order to decrease the pressure, the forward reaction will be taking place. Now we will see in the other case, if we decrease the pressure, if we decrease the pressure in the system, and the system will try to increase the pressure. How it can increase the pressure? The only way, the number of moles, if it is increased, then the system will be increased. So in which direction it has to move to increase the number of moles? So it will be towards the backward reaction. So ammonia decomposition will be favored in decreasing the pressure. If you are decreasing the pressure, the system will try to increase the pressure. In order to increase the pressure, system has to go in the direction for the backward reaction, so that more nitrogen and more hydrogen will be produced.